underwater vehicle is a prime example of what you can do with the ocean engineering field. There's a ton of engineering that goes into this little vehicle, but as an ocean engineer, you could also choose to do other things like coastal engineering, important things like how you dredge certain areas, or how you build a pier or coastal structures such as breakwaters to help protect our coast. But for my path, I went to Florida Tech for my degree, where I started out the very first day of school. My professor said, "Hey, what are you interested in?" So I did, and I ended up working on these types of vehicles. So from there, I found out about certain types of scholarships, which I applied for and was able to get. And so from my internship and scholarship, I was able to acquire a job at the Naval Surface Warfare Center in Panama City, where I will be working on a underwater diver controlled vehicle called the SEAL delivery vehicle. So a scuba diver is going to go down, they're going to sit inside of this vehicle, drive it around, perform some type of mission, and then come back. But the engineering that goes into it is what I'll be working on. Can you guys hear me okay? Okay. So that's kind of how I started out, and along the way I gained a ton of different hobbies, including scuba diving, as well as other ones along the way. My favorite is scuba diving for megalodon shark teeth. That was really fun. So finding a way to incorporate these fun adventures into my degree was how I ended up liking my degree more, and just made my experience that much better. So, what type of questions do we have?
Yes. Where do you find clear enough water to dive for those shark teeth?
Can you ask the question again?
Where do you find clear enough water to dive for those shark teeth?
So,
Can you repeat the question?
So the question was, where do we find clear enough water to dive for those shark teeth? Actually, the water is, I went to Venice Beach over in South Florida, but the water is actually not very clear in that area. You can only see to about here. And I've also dove in worse conditions than that in Cape Canaveral, where you can only see to here. And your dive buddy, you have to link arms with them to be able to go out and get anything accomplished. So we were in Cape Canaveral performing underwater drilling. So we had a drill that we got from Harbor Freight that in any way would not be for one-time use, and we were drilling underwater for a couple hours for our ROV mission. So that's the kind of hands-on stuff you get to do with ocean engineering.
What was the mission in that case?
What was the mission in that case, if you can share? Yeah, so that project was an ROV that would go out to a certain target and apply a certain object onto the target, back away, and then it would run basically explosive missions. So that project was a contract for the Navy, but I was able to join it after my second semester in college. So that really kind of kick-started my love for robotics and in the water.
Can you describe some of the different projects that you've worked on, some of the different technologies that you've helped to engineer, or some of the different challenges that you were helping to address, for whether that's Navy, or I don't know if you've done any for research or different kinds of applications like that?
Yeah, so the same project I was just talking about, the EOD project, I was mainly focusing actually on electronics. So I would do all of the soldering for that project, redesigning and Tetrising our electronics to fit in these really small enclosures. And so that kind of showed me how broad ocean engineering is, because I wasn't just working on the mechanical structure. That I was in the nitty-gritty electronics. But another project that I had worked on actually had to do with rockets, and you might not expect that from ocean engineering, but that first semester they said the goal of this project was to launch a rocket into the atmosphere and collect data in a hurricane, and they wanted to do that all from a buoy. So in that semester, we designed this rocket to go up and launch in the atmosphere. We went out in a storm and launched it. The first one went up about 5 feet, turned sideways 90 degrees, and luckily went away from the vehicle we were standing in. But yeah, so that just kind of shows how much of a variety my degree can provide.
Can you describe some of the potential applications that you might be working on in the future? So your Navy position that you're about to assume is a term limited. Am I remembering that correctly? And so then after that, you might be moving on to a different project?
Yeah. So the scholarship that I went through is called the SMART Scholarship. It's open for any high school seniors or college students. And if you get that scholarship, you can get your entire school paid for, and you get a stipend. So I'm getting paid to go to school, or I was getting paid to go to school. The only contract was that for however long they pay for my school, I also get to work for a certain Navy base for the same amount of time afterwards. So for me, that contract was for 1 year because they paid for 1 year of my school. And so I will work for the Navy as a civilian in Panama City for at least 1 year, but I could keep working for them if I enjoy the program, and it just gives me a kickstart of an easy way to get a job, pretty much.
Career opportunities would you have after you fulfill this commitment to work with the Navy if you choose not to stay with them?
Yeah.
Can you repeat the question?
Yeah. So the question was, what type of career opportunities I'll have after this commitment with the Navy. But if I decide to stay with them in that program, then I can work my way up. So they have a staircase raise program where you advance in your engineering career. So I can follow that path if I wanted to. But I could also, if I decide I don't like the group I'm working with, I could also just transition to a different job, get hired somewhere else, likely with a higher pay, and then go from there. So I have also worked other internships, one of those being a high-speed boat. So there's this group in Melbourne called MARTAC, and they create these 12-foot long boats that can go 70 miles an hour. So I worked with them, got to drive out on the water with those boats. So that's another option for me that I could pursue if I wanted to in the area.
So could you just talk broadly about the field, like what kinds of things? I know you mentioned some, different kinds of engineering, like with
projects or,
construction, but like more specifically, like with the underwater robotics, like maybe some of the research applications, or like in a field, like maybe in the oil and gas field, just kind of broadly some of the different kinds of applications people use the underwater robotics for?
Yeah, so underwater robotics is only a portion of the ocean engineering degree, but even just within that portion, you can do a whole different bunch of things. Like for me, I was working with the Navy and will continue working with the Navy, but you could also work with the oil and gas industry, who on those big oil rigs like that you see out on the coast, they can go out, take a vehicle, submerge it, drive it from the surface, and go survey the oil rigs and see, oh, is something broken here? Do we need to send a diver down to fix it? It just kind of helps them limit the diver use and use this cool technology for other purposes. But there's also research applications. So one of these is in the college space. You can kind of research ROVs, and for me, for example, I did a senior design project with an ROV where we created this small little ROV about to have a handheld controller. The diver could operate this vehicle, send it out as a scout ahead of them, or just explore areas that they weren't certified to explore in. So that's another application. You can kind of see how the research connects all back to the ROVs, and there's a ton of different applications. As a college student, you can, our degree, we could select what specifically we wanted to do for our design project. So it was open to anything. We didn't have to choose scuba diving or even ROVs, but we chose that because it had such an application in the industry. And we actually, instead of seeing something like this that's all hard and aluminum or some other material, we actually 3D printed our ROV entirely. So we created this resin printed body that housed our electronics. We were able to accomplish that as a second mission of our senior design project. So kind of seeing how the new technologies not only potential research applications, but 3D printing and all of that can apply as well in this degree. So,
Can you point out some of the
kind of
design features of this ROV? And can you go back
and just
describe what an ROV is, what ROV stands for, and then if there are some kind of consistent design features of an ROV that you can point out, and then maybe point out some things that might change from from one ROV to another?
yeah, so this ROV specifically, and most ROVs have this front dome where you normally have an internal camera, so an operator can see what's going on while they're operating it. As well as they have this main body chamber that houses the electronics, so that's consistent with most ROVs. And then all of the ROVs also have these thrusters so that it can move forward, backwards, side to side, and up and down in the water column. Something else that's consistent with the ROVs is you have to be able to sink it and be able to make it float. So to do that, you either have vertical thrusters like these but pointed downwards, or you have to have a buoyancy compensation system where you can take air into the system or out of the system to be able to go up and down, because you have to be able to get to your target somehow. So if you're going down to the oil rig, you control your ascension and descension.
so are some of these
Tethered and some untethered with somebody at the surface, or are they all, is there a cable that goes to the surface for all of these? Can you kind of describe the logistics of operating these things? And how much time do you spend time operating them, or are you more just designing them and building them?
So the first question, these vehicles are all tethered usually, because if you think about a normal flying drone in the air, it just connects over Bluetooth or cell service or Wi-Fi, but Wi-Fi and Bluetooth can't go through the water, so you have to have a physical connection from the ROV up to wherever your controller is. So that's consistent with most ROVs. Some fancy ones will get into using sound waves to control ROVs, which I have not touched. It seems a little bit above my area of expertise, but yeah. So, and then the second question was, if I operate them or just do engineering. I do a bit of both in college. So we had a team of 3 people working on one ROV. So we had to do everything, the engineering, the testing, and so we started out in the lab just on the whiteboard with ideas, and then we created the thing, manufactured it, and then went to the Cape Canaveral where the rockets launch, put it in the water, dove it around, tested how it ran in the water, And we actually got to go to San Diego for that project twice because we were testing it with the Navy base that's out in San Diego. They had some specific things they wanted to see on how it works and things like that. So.
You do it when you're testing, you drive the ROVs. Do you expect to do a lot of like ROV piloting for the practical applications, or is that like you're just testing it to make sure it's functioning properly? So, I mean, just asking because we know somebody who's an ROV pilot, so he's not developing the ROVs, but then he will pilot the ROVs that's the technology that's given to them. So are those two separate jobs, or do you expect to spend a lot of time piloting an ROV?
Most of the time, at least in the industry that I've seen, the engineers are also the test pilots. So you'll have, there's certain cases where they aren't, but most of the time, at least in San Diego, those engineers would go out on the boat offshore and test their vehicles, drive them around and perform missions. But the only time they would bring someone else in is if they're testing it for a customer. They want to see how people who have never drove one before can drive it, make sure it's kind of easy to use and things like that. But the big high-speed boats I was talking about, they have specific drivers who that's their only job is to drive it. The engineers will drive it, but they tend to leave it more towards the pilots.
Do you all have questions? Any questions?
Do you have any, like, have you ever had an experience where you get out there and you think everything's going to work and then it doesn't? Or maybe like, I guess maybe one of the biggest problems that you've encountered in your testing?
Yeah, so the biggest problems we've encountered during testing have mostly been involved with the system, not the system on our ROV that we created, but something else that a different company tried to integrate onto our ROV. And I can't talk specifically the details about that, but just know that we have to kind of work on the fly. And we have had to for this at all because it never happens, but those are the things that pop up the most. So.
Do you have, when you're building something like this, when you're testing it, I mean, I don't know if you would test it throughout, because I would think that there would be some special design challenges with building one of these so that it can operate in water, especially salt water and at depth with high pressure. Do you have a lab where you can test these things, or do you have to test it all out in the field once it's kind of fully constructed? Do you test it along the way?
Yeah, so most of the time we test it along the way, but so for an aluminum enclosure like this, we've designed it in our 3D software and simulated a test in our software, and we have a pretty good idea that that'll work. So for stuff like that, we'll just go out and test and not worry about it failing. But for something like our 3D printed ROV, we've never seen how these things have acted under the pressure of the ocean. So could it implode like OceanGate? We're not really sure. So we put it in this big test tank that can feed pressure into it and simulate ocean pressure. So that's how we test to make sure without our valuables inside, how can we test this and make sure it won't implode? That's how we do it.
Let me ask you something. In your career, when you're setting down the law, are there any specific goals that you would like to accomplish, or something that you would like to see develop in your field over time?
So for my personal goals, I would like to be more involved with the testing side of things because I think it's more fun than just sitting at a desk and designing. The test planning, the actual physical test, and then the write-up of what happened in the event. So that's what I'll try and incorporate in my career, but I don't have any specific ideas for, hey, I want to go off and travel in my career. I don't really want to do stuff like that. So.
When you're testing, do you get in the water with the ROVs, or is that a big no-no?
So we do actually get in the water with the ROVs. We have normally 2 scuba divers. They're both scientific certified, so that scientific dive program I was a part of as well. But myself and one other person were usually in the water with the ROV, where we had one person kind of holding on to it because it didn't have the vertical control. So our scuba diver was our vertical, they would make it sink or make it go back up. And then I would be just sitting there taking video of what was happening. So that video really helped with our test reports and making sure we knew what happened while the test was occurring. So, does that answer your question?
You mentioned a testing tank that can simulate the pressure of the ocean. Is that at the Naval Center? Is that something that's kind of afforded to you through working with the Navy, or would a lot of designers have access to a similar kind of setup?
So it depends on who you're with and what resources you have. At Florida Tech, we did have one of those test tanks. It was given to the school by a local company, but the Navy also has access to tanks that were even bigger than the ones we were using. They span like the full length of a room, so you can put scale models inside of the tank. So I will have access to that as well in my career.
When you were designing the 3D printed enclosures, how deep were you able to get them, and did you ever test them to destruction?
So, yeah, so the 3D printed enclosures we had, did we test them to destruction, and how deep could they go? So we started out originally with these little baby light enclosures that we sunk into the pressure tank, and they actually imploded right at the depth that we expected them to, so we were very happy about that. It was within, if y'all are scientists, it was within 5% error, so that's really awesome for our research. But what we actually did with our ROV, it was too big to put into the tank, the enclosures that we had for it. So those ones we did not test to implosion. We didn't get to see an explosion for that because it could have potentially harmed the tank that it was in because there's so much air volume inside of that enclosure. So we just kind of were hoping that our processes were correct because we saw that 5% error with our previous enclosure, and we did that simulation on our computer to make sure that it wouldn't implode at like 30 feet or something ridiculous. But we actually took those simulations and said, let's scale this down, and we did a little bit bigger of an enclosure to make sure our calculations were still correct, and that one turned out good too, so we were pretty confident that our ROV could survive.
What depths? Like what are you talking about? So what depth are you talking about?
So for our ROV, that one was designed for the scuba diver, so it was maximum of like 230 feet. You wouldn't really need much more than that. But the actual implosion depth was, I believe, like 530 feet. So, but we had a safety factor added onto that, so it would have been much deeper considering that. So.
What are you most excited about doing with this project, your upcoming project with the Navy, and then I know you mentioned being involved in the testing. Is that going out on boats? Is it diving? What are you most excited about with your project and then beyond with your career?
So I'm excited to get to learn the whole system again because I need to get familiar with it in order to be able to test properly. But once I get to learn it, I'm stoked that I can go out onto the boats and supervise what's happening, so I can actually get certified through the Navy to operate their boats. So I can go out and be the primary coxswain for one of their boats. So that's pretty cool to me. In that I could go out, see what's happening, and just be on the water. But I could get scuba certified if I wanted to through their program to actually dive the vehicle itself. But that is a Navy SEAL course where you get like pushed under the water and just torn up. So I'm not sure if I want to do that quite yet.
Wow.
Yeah, they said that the Navy SEALs in that course, I have an engineer who's a friend that went through the course. He said that several people passed out just in the water, and they have to do that to pass the course. So yeah, my mom doesn't want me to do it.
I don't know if this, I mean, I know that there might be like proprietary information and maybe some of these questions you can't answer, but could you talk just really generally about some of the other projects that the Navy might have for these kinds of, for these kinds of individuals like yourself who would work for them as civilian engineers and do projects of this nature?
Yeah, so one example of ROV work that the Navy does, you can look this up online, so it's nothing too crazy, but they're creating this Dive Buddy ROV in Panama City, where as a scuba diver, you're down there accomplishing a task, but you have this little ROV next to you with handles on it. You can use it as a scooter to mosey around, or you can use it as like a tool placement device, as a toolbox pretty much for your operations. And then the Navy over in San Diego, they have a whole entire fleet of ROVs, so they're able to go out and use those anytime they want. So applications like that where they get to engineer something with the ROVs to integrate is pretty cool. Any questions?
Do they use them in hostile environments? Like I've heard that they can take them into, right now with the Middle East, like Red Sea and stuff, and kind of explore to see if like mines and that sort of thing. Is that something that is done, or is that stuff that you're not supposed to know, or whatever?
Yeah, I mean, I don't know what specifically they use ROVs for, but just, think about the potential applications with the EOD project and things like that. Mines are a potential use.
The problems you have with implosion is usually related to air, right? Do you ever replace that with oil or some other liquid that wouldn't have that problem?
Yeah, so if you're trying to go really, really deep into the ocean, like ROVs on the Nautilus who get to go down and explore like the Marianas Trench and stuff like that, they will take these enclosures and backfill them with oil or something like that has a little bit more viscosity. So all of your pressure going into the enclosure will have pushback from the inside. So it doesn't seem like as much pressure even though you're down that deep.
Thank you. That seems like a very exciting field to enter. Thanks for chatting with us about it. It's a little bit different than a lot of the talks that we have here, which are often very research focused. And so it's kind of interesting to hear from, some different kinds of industry applications or military applications for this kind of technology. Thanks for coming and talking to us about it today.
Yeah, of course. If y'all have any other questions too about like college process or anything like that, let me know.